Hello friends, today we are beginning a series of videos on high performance computing. The topics which are going to be in this playlist are openmp, then Linux for HPC, then CUDA programming, and also the machine learning. So we begin with the openmp, the programming language for writing parallel programs on shared memory architectures. So we will come into shared etc. later. Let us begin in very simple form. What is openmp? It is like an API. So it is like you write the program in C language or Fortran or C++, and this is an application programming interface. So you include a library on top and start with it. So it is not a completely new programming language as such I said. It is built on C or C++ and Python. So it will look like a C or C++ program for you in the coming videos. Now, and it is OpenMP is generally used for loop level parallelism, and it also supports functional level parallelism. We will see all those things later. So a typical C program looks like that. You basically write any C program, and you create an executable file and runs in on a processor. That is what you do. Now, when we do all these things, so this is a program. This is called a passive entity, and this is called an active entity. Exe is called an active entity. So you can now see the difference between passive entity on the left and the active entity on the right. Now, what is a thread? And thread is a lightweight process. For example, in the previous video, on the right hand side, exe is going to be a process running. So now thread is a lightweight process. Now multiple threads can be spawned inside a process, and threads can run parallel. And instead of creating multiple heavy processes, it is like a very huge program, having an exe, something like that. Don't think it like a process which has to be so heavy only. No, we can create multiple threads within this process, and we can run them parallelly. For example, this is a program. So you are trying to do for I is equal to 0, and you increment till 100. So it is not necessary you have to run it in one go as a big process. Can divide into 4 different processes. 0 to 25 iteration will go in process 0 and will run on core 0. Core 0 is the first computer. That in CPUs and GPUs there are many cores. They are like multiple processors, embedded processors. So core 0, it can run core process 0. The 25th to 50th iteration can be run on core 1. 50th to 75th iteration can run on process 2, that is on core 2, and the last one can run on process 3, that is 75 to 100. So this way you can divide the processes. The complete loop gets divided to 4 processes and executed on 4 cores of as distinct processes. Now in a multi-threaded execution, so earlier we said multi-process execution. Now we are saying multi-thread execution. You can run as a thread 0 to 25. You can run in thread 0, and you can run in core 0, and 25th to 50 you can run as a thread 1 in core 1, So then, so processes are again divided into threads. So the complete loop gets divided among 4 threads and executed on 4 cores, different as 4 distinct threads of process. So each process now it is, it is in a threaded programming. Multiple threads are there, and so they are nothing but sub processes, I said, and you can divide like this. Now this is how typically an openmp program, parallel program looks like. See, whatever is written in the pragma of OMP parallel, you're telling the compiler that within whatever, within these brackets, whatever is written, it has to run parallel. That means parallel means where it will run in different threads. It depends on how many threads are available, or each thread runs on a core now. So now if there are 24 cores available to a computer, 24 threads will run. That means 24 times this printf will be printed. And each thread will have its own thread number, which can be identified by a single OMP get thread number. So this program will print, maybe if it is a 24 core processor in which you are going to run this. So that means you are going to run it on, you are going to get 24 output, something like that. Then this entire portion will run parallel. The overload is written in parallel. That means it will go and run in as individual, individual cores will run it independently parallelly. So that means if it is having 24 cores and 24 threads will run parallelly, this is what I'm trying to say. Now this is a very simple program. Now, here you can see the directives are defined by openmp, take different forms depending on the host programming language. See, pragma is used as now directive, and in C++, the curly brackets left and right, within which the parallel programs run, I already explained to you. And we use 2 terms in openmp to describe code executed by an openmp program. That is a directive, which I told you at the top, which is like the pragma is the directive, and directive is structured, and its structured block is called a construct. And this entire thing, and a directive and its structured block is called this entire stuff which is in the square, which is called a construct. Now, so what is a construct within the curly brackets along with the directive, that is a construct. So this is a program which is going to run parallelly in multiple threads. How many threads are available according to that? Because we have simply said parallelity. How many threads you have to run, like etc. we didn't say. So it will randomly take all the threads available to this computer. So this is how it is. The construct is this, the directive is this, and now you need to master a few elements, like what is compiler directives, what is a runtime library routines, what are the environmental variables. Some things will cover in the next videos. Now I am going to go to a kind of executing a program in so-called in a supercomputer. I have just logged into a supercomputer, and you are getting a prompt like this. It is like, if you see, it is simple Linux machine, supercomputer. So if you ask what is the OS it is running, we can always just print it out. See, it is simply Alma Linux 8.1. 8.1. This is nothing but a Linux version. Like you must have used Ubuntu, etc. So this is Alma Linux. So that is the only difference. Now working with openmp will be very, parallel programming is very easy if you know the basics of Linux. That's why we are going to have a series of programs on basics of Linux and how to execute a program in a HPC, and also what are the basic environmental variables you have to know in Linux, and what is environmental variable in Linux, etc. will be discussed in the Linux section separately. Now we are continuing with the openmp for a few days. So the program, I have kept some programs in this, so I am going to execute the so-called hello world C program. So what I can do is see, this is just a command. You have to G++, and it's like a C++ program, and you have to say -f openmp. So it is executed. Now if I say a.out, see, it is right now running hello world 4 times, something like this. Now if you want to see what is this program inside, we can go and see. Here, unlike earlier I told, here I have forced openmp set num threads 4. I have forced it to only run it on 4 threads. That's why it ran it on 4 threads. Let's see, whatever it ran